Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ahmed Hegazy from SEG CAD Solutions. In this video, inshallah, we will discuss the concept of the UCS, which is the User Coordinate System. This concept used in SEG software to define the start and the end of each main element. Like here in this image, for the flange, as you can see here, we have the start UCS and end UCS. The start UCS located at the beginning of the element and the end of UCS located at the end of the same element. That means when you add another element before the previous element, the start UCS for the second element will be connected to the end UCS for the previous element. And there is a concept here. You can use it for making gaps or overlap. By using this option, you can make a gap between elements by moving the UCS by creating an unreal element to move the user coordinate system from the end of the previous element to another point. As you can see here in this image, we have a gap between this head and this shell, and as you can see with this reducer we have an overlap. This user in the default option will be connected to the end of this pipe, but here we have an overlap. This overlap gives us the ability to move the user coordinate system to this point, so the reducer will start from here, not from this point. Now let's give an example, a real example. Here we have this case. So let's create a pipe here with 320 millimeter length. So let's add a B1. Let's make it, let's say, 10 inches with the schedule 80, for example. And for the length, let's make it 320. And here's the outside diameter of the pipe. And now let's create this pipe. It will be like that. And now let's make a reducer. And the reducer length will equals 1430 plus 2347. So that's the reducer length. Okay, so from here let's define the inside diameter. So we could increase the pipe diameter. Let's make it 24 or make it as a shell. Let's make it 700 millimeters and the length be like that. Let's click on save, and now let's reset the inventor model and let's add a reducer after this pipe. So from here let's add a reducer from plate. So the inner diameter will be 700 and the end diameter is 377 as a thickness, and the longitudinal welding line orientation, sorry, that will be the height, sorry. And here for the end diameter it's 2430. Okay, and let's click on save. Now let's create the assembly of the shell and reducer. Now we need to flip the values. Click on save, and now let's rebuild this reducer. Okay, now we have this reducer. Let's create this can with length, let's say 1 meter. So from here let's add a can. Here we have this diameter, and the length, let's make it 1 meter, and click on start to start creating this scan. Now when we try to add a small can here with 2 meter point 1, after that another reducer, if we add that by default, like adding can 2 and define the inside diameter to be 1 meter, 2 meter and 100 to be like that, and define the height to be 330 to be like that. After that, adding a reducer, here the small diameter will be like that, and the large diameter will be 4370, and here the thickness, and the length of this reducer is 4238, and now let's click on save. Now when we try to generate that, you will figure that this can comes at the end of the previous can. Okay, it comes like that. So we need to move this can down to make this shell touches the reducer outside surface. Okay, now let's prepare a drawing to measure the required offset length. Now let's make a top view like that, and let's take a half section. Let's take a half section, okay, like that. And from this section, let's make a sketch to measure the required distance of offset. So if we measure this value, the length of this line, it's with that value. So if we move the connection point here down to be with that value, let's try that. So from here, let's select the equipment, and from here, let's add a gap. Okay, and name it is overlap 1. And this overlap, we will need to select this option and define this value to be 944.811, 781. Sorry, 781. I hope it's yes, it's like that. And from here, this overlap should be between this can and that can. Okay, so we need to add this overlap after can 1. So from here, let's move this one. So from here, move after can 1. Okay, so by that way, as you can see here, we after can 1, we make an overlap to remove the user coordinate system down with that value. After that, we will connect this can. Now let's start the assembly to start the modification. As you can see here, if we come back to the drawing, you can figure that. Let's finish the sketch. As you can see, let's delete this sketch. As you can see here, we have this overlap to be like that. So we need to adjust this value a little bit to make it not clashed with the reducer. So we may need to measure this distance again. So let's measure that value from here to there. So need to reduce that value. Sorry. So let's take this value, copy, and paste it here, and update the model. Now let's come back to the drawing and check the clash. As you can see here, it's clear now. Now let's make another connection. So after this reducer, we will add another can with 4370 diameter. So let's add can 3. So the diameter will be like that, thickness, and the height of this can, let's assume it to be 1200, and let's add another reducer. Here's the start diameter, and sorry, we have another can before this reducer, so let's keep this can, and let's say the diameter 6 meters at the end, and the height of this reducer 1679, and click on save, and let's add can 4. This can will be with that diameter, and the height to be 470, and click on save. Now let's move this can before the reducer, after can 3, after let's reduce this, let's move this reducer after can 4 like that, and let's start creating the assembly. Here for this can, as we can see, it's 3900, so we need to change it from here, 3900, and that value will be the smallest diameter in the reducer, so we need to change it here, and click on save, and click on update to update this can and the reducer. Okay, now let's change the longitudinal building line orientation of this reducer to be like that. And after that, we will check how much we will need to make an overlap. So let's come back to the drawing and make a new sketch. Select the same sketch here. Let's extend this one, and let's project this line and that line, and from here let's extend to meet, and let's measure this line length, and now let's add overlap. From here we could take this overlap as a copy and paste it here and name it as overlap 2, and click on rename, and from here we can change the value to be 826.916, and click on save. Now let's click on start assembly to add this overlap, but this overlap should be between this can, which is can 3, and between can 4, so we need to move it. So from here let's move after can 3, Okay, so this overlap should be between both of CAN 3 and CAN 4. Now, as you can see here, if we make a half section or a quarter section, now we have this connection to be like that. Okay, let's come back to the sketch again. Click on finish. Now we make this type of the Cyclone parts with an overlap between shell and reducer. I hope in this video we cover the option of the overlap and gap and how we can deal with it. Thank you for your time. Assalamu alaikum wa rahmatullahi wa barakatuh.